Okay, so let's begin with the 25th February shift to JEE Mains 2021 organic chemistry questions. And the first one here is interesting because you have oxalic acid and ethylene glycol. Okay, and you heat it. The first thing which comes to mind is esterification, right? So nucleophilic substitution reaction, esterification. This alcohol can attack here, and don't gonna go into the mechanism, but you can get this diester. Should make it properly in a six-membered ring. I can see here. Yeah, and what next? This is not an option. So what next? Mm-hmm. High temperature, a very important tip. High temperature could mean that any reaction in which a molecule is decomposing. So those kind of reactions will get more favored because delta G is equal to delta H minus T delta S. So processes with delta S positive at high temperature, they will tend to have more negative delta G, so they will become spontaneous, and it's very obvious whenever you heat something it tends to decompose, right? So yes, I would like to go with a product which is decomposed, and like this thing, if it decomposes, and we are very close to CO2. You can see CO2, you know and I don't know about the mechanism, but I can see that if this happens, suppose this, it has two lone pairs. Yeah, it has two lone pairs. Yeah, so this bond breaks, this electron here and this electron comes here. You can see CO2 getting formed, and this breaks and this breaks, and these two electrons here, they can make a, yeah. So my intuition says this. All these products are very stable, thermodynamically stable. This, and they, we get three fragments, so what more should I be looking for? And I go with this one, CH2 and carbon dioxide. Okay, now let's see the second one. Which of the following statement is correct for the given reaction? And this is a reaction. Okay, this has been already asked in the previous um, 24th February question paper in one of the shifts. I don't remember, but this has been asked. So this is in NCRT, and you know that aniline is orthopara directing because NH2 shows plus R effect, and it should be orthopara directing, but the meta form turns out to be quite not expected. You wouldn't expect the meta form to be this much, but meta form is in good enough amount. So what is happening? What is the question? NH2 group is orthopara directing and product 3 would not be formed. No, 3 is formed because in acidic medium you get anilinium ion NH3 plus, which withdraws electron, and this NH, because this is N positive, so there will be minus I effect. It will withdraw electron and it will be deactivating and meta directing. So meta directing, substitution of NO2 on meta is also possible here, and it's in good enough amount. So reaction is possible and 2 is major product. This is wrong. Reaction is possible and 2 is major product. Reaction is possible, of course, product 3 is major oh my god, this is not good. Because you would have to remember the exact percentage, and as far as I remember, it's very close to 50%. Like the ortho one is very less, it's like 1 to 5%, I don't remember exactly. And this, out of these two, oh god, this is not expected. This was not expected to be asked. Like, this is very memory based. And then sulfonation, this is wrong, this is wrong. Reaction is possible, Product 2 and 3. Wow. So this is a bouncer, and yeah, this is a bouncer in the because I remember the figure from the last, when I saw the last paper, it was something around 40 to 50. I remember this one, so I have a faint memory. I will go with the option 2. Like para is still the major product if I have to go with, but this is not right because I saw this yesterday while solving the last paper, and even I'm not sure, but I feel like this is the right answer, but not expected in JEE Mains this kind of questions. Now the next one, consider structure correct structure of alpha anomer of maltose. Okay, maltose 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 starch. From starch you come to maltose, and from maltose you go to alpha D glucoses, alpha D glucose units. Alpha D glucose units. Alpha D glucose, very easy. For me, how I do it, I know the beta D glucose is the most stable form of glucose, and it's most abundant in nature. So I know the CH2OH is up, then all the bulky groups, they are opposite, and this is beta D glucose, glucopyranose to be more exact. And then if you want alpha 1, then you have to replace this OH, and because this is the anomeric carbon, here you will have to put the OH down, and this is your alpha D glucose. And of course the C1C4 connection will be seen here in maltose. In amylopectin, in starch, in amylopectin you use C1C6 cross linkage, otherwise most of the times you have C1C4 linkage. So then now we understand alpha anomer. So yeah, this is very interesting because maltose, as you see in many textbooks, you see the structure of maltose, but the second ring can open up, and the second ring can go into alpha or beta, both configurations. But anyways, let's first think about that both the units should be alpha. The first one should be alpha. Let's first think about that. So you have CH2OH and OH, 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 and this O is down. Yes, this is alpha, and this one also is same, right? Because here is the glycosidic linkage, and here was the OH, here was the OH, and down, down, down. Yeah, this is the right answer. And why this is written alpha anomer? Because this ring here can open up and readjust into beta position. But yes, this is the correct answer. What's different in other examples? This is beta. This is beta maltose, guys. This is beta maltose. And here, these two OH are together. No. And in the last option, once again these two OHs are together, hydroxyl groups. So no. So you have to remember the alpha D glucopyranose glucose, alpha D glucose in pyranose form. You have to know the configuration. For that you can reach it through beta D glucose unit, and beta D glucose unit have everything, all the bulky groups you see in alternate form, and this is the anomeric carbon. Here you, if you change the OH to the other side, then you get the alpha D glucose unit. This was a good one. Now let's see the other one, which is the correct order of Ka. This is based on acidity. Acidity, very easy. Okay, you have carboxylic acid, benzoic acids, and then you have all of these are benzoic acid, and then there is a phenol. So of course phenol is very less acidic than benzoic acid, because in phenol the oxygen is at only one oxygen, the minus charge will appear at only one oxygen, and it will be shared by 3 carbons. But in benzoic acids, which are carboxylic acid, in any carboxylic acid, if an H plus is released, the O appears at one oxygen, can be shared by the second oxygen also, and 2 oxygen is much better than 1 oxygen plus 3 carbon. So very basics of acidity, if you remember. And among these 3, you see this is an electron withdrawing group, so it will increase for sure the acidity. There's no substituent at the ortho position, which might have made it a little bit difficult. But this CH3 group is not at the ortho position, otherwise it would have been an interesting question. But all of them are at para, both of them are at para. So most acidic is C. Most acidic is C. Then you have A, then you have, and this is Ka, right? Not pKa. Perfect. Then you have C, then you have A, and then you have B, and then you have D. Perfect. This is the correct order. Interesting. Why in all the options I see D, all other options I see D is considered most acidic? Ah, it's not pKa. So we are right. C is the most acidic. Let's move on to the next one. What's happening here? Okay, this kind of question, you have to identify the correct reagents which should be used. Let's start from the first one, benzene, and then you use this reagent. This is a Friedel-Crafts acylation, and you get COCH3, and then you, okay, Clemenson reduction, then you have CH2CH3, and then you use Br2Fe. So going with the para attack first, and then you use nitration. So ortho now, which is the meta of bromine. Bromine is also ortho para directing, but if you go into the electron densities, um, it is close, but I think still C2H5 will be more important here, and we can get this one. Let's hold on and check the other options. First one now, second option you use Br2Fe, then you get a Br, okay, then you use CH3COCl and AlCl3, then you do the acylation, and this time the acylation will be at ortho or para. So we'll go with para. Remember, this is very interesting that halogens are ortho para directing but slightly deactivating. And CO, this is also going good. And then Clemenson reduction, C2H5, and then finally nitration. Wow, both of them till here, both of the options reach to the same kind of situation. And introducing bromine early is not a good idea because it's a deactivating group. So introducing bromine later on would be a good idea, I think. So if I have to go with one or two, I will go with one. So still one. Now let's come to this. Introducing HNO3 early is not a very good idea, but anyways, let's see if there is some clarity about the position, then it might be considered. NO2, and then at the meta you have okay, at the meta you will get this COCH3 and then Clemenson reduction. So we need to have this at ortho, right? So this is not the answer. Fourth one, you're doing this thing first and then nitration. This will also not give you the right answer, because when you come to after this you are at ethyl benzene, and then you use a nitration, then the nitration will be at at para, and it could be at ortho also, but para will be more favored because it's sterically less hindered. Well, so what I feel like we will have to go with one, guys, one. I would like to go with one. Let's now move on to the next one. Okay, how about this one? You have H2SO4 and you have this alkene here. Okay, nice. So this is about you will make a carbocation here and you will have to attack it at the benzene ring. But which side? Carbocation? Don't think about Markov-Winkov rule, because Markov-Winkov was way earlier than all these exquisite chemical bonding theories and understanding of molecules was discovered or maybe invented. So you have an H plus, and if you attack this H plus here at the corner, then you get a plus here, which is not a good idea because NO2 is highly electron withdrawing, and it shows minus I effect. So this is not a good idea. I would like to attack the H plus here and generate this carbocation at the corner, which is primary, I understand, but still because there is an NO2 group, I would like to prevent the H plus from the NO2. And then I would like to attack this on the benzene ring, which will give me from here, this gets connected to the benzene ring. 1 2 1 2 3 4 1 2 3 4 1 2 3 NO2 on 3. Is there anything like that? Here we go, the fourth option. I would like to go with the fourth one. Great. And this is the last one. This is the last one. What is this about? Okay, you have carbon monoxide and hydrogen, and this catalyst hydroformylation, guys. Hydroformylation. Oxo process. Oxo process. So this has also been asked before in this year, and for the preparation of aromatic aldehyde. And this time this will not occur. This will not be used to make an aromatic aldehyde, but very much similar kind of situation, and can't go into the mechanism because it's very complicated. It's basically, you have to think of adding a CHO group, and this is a double bond. Adding you see H2CO, you can think there is an H involved and a CHO involved, and both of these things will get added, and it could get added anywhere because I don't remember the regio selectivity of this process, and this is industrial process, so that could be very complicated. It's not a process which we do in the laboratory, and we might have some better studies for this one. But anyways, if from that, if anything is clear, let's see. If I add a CHO here and an H here, then I get this thing, or if I add a CHO here, then I get this thing. Is there anything like that? 1 2 3 4 1 2 3 4 5 carbons. 1 2 3 4 carbons. No, 1 2 3 4 5 carbons. This might be true. Oh, and in other processes we don't even remove the double bond, so yes, I'll go with 2. Thank you very much for watching. It was a nice experience solving this question paper.